Hello and welcome to this section. In this section, we will learn a data variable such as one-dimensional array. In this section, we mainly include the following contents. First, we will talk about the introduction of one-dimensional array, and then we will talk about the use scenario of one-dimensional array. Finally, we will introduce the basic usage of one-dimensional array. So let's start with the introduction to the widget of one-dimensional array. First, the one-dimensional array is organized by E in order. Note that it is organized by E and each value position has index marks. From 0, it is a single row and multiple columns of data. The linear structure of the data is like this. What is the result like? Is it like we have an Excel table with only one row, so you see that in each table, it writes a series of values, so note that it is an organization in which each grid can store an independent data type with one element, including our text values, pictures, and actually our special functions can be a text color is also our special function of the text and so on. The use of data type can be declared in advance. For elements that do not declare a data type, the system will automatically make a declaration according to the data type. So let's combine the two figures. Let's take a look at the data called A, which exists in the data with 0 index number in our one-dimensional array, and a value such as WebView exists in our one-dimensional array. Therefore, the only such value in the future will be told when we study strings. Yes, as far as we are concerned, in our programming, we have learned that it is related to its order. Basically, we start from the 0 position, that is, we must not forget the 0 position. Then let's talk about some usage scenarios of one-dimensional array. A 1-bit array is usually used to store an ordered sequence of numbers. We can easily perform sorting, comparison, and other operations on it, and output our final operation results. Then, generally speaking, one of its usage scenarios is to record a set of dynamically changing data. For example, we are doing multiple topics because the user cannot estimate what values the user has selected, which is convenient for us to add or delete data. Therefore, we may use a one-dimensional array to record some values selected by the user. Secondly, the one-dimensional array will be used to arrange a group of data. For example, we want to arrange a group of words according to the initial letter, or arrange them according to the size of values in a 1-bit array, which can be implemented very conveniently. Then let's take a look at a bit array and its basic usage. Again, let's open our editor, enter a one-dimensional array in the application name, and click our Create button, so we complete the creation of our application. Then we select the frontend to form a good habit. We first add a page under the frontend, and then we add our bit array in the page. Where is the dimension group? Let's look for it. In fact, looking at the icons here, we can clearly see that there are 3 dots here. Is it a special image that shows such a row of data? Yes, such an icon is our one dimension. The group is just at the bottom of our Boolean variable, so we click it. You can see that we can add such a one-dimensional array under the page, and then know how to add it. Let's take a look at one of its properties of our one-dimensional array. We can see that the property of a bit array is directly put here, and we can add it for you. What is it like? Is this like an Excel table? There is only a plus sign here, that is, let's add a column of data. Here we click a plus sign. When we click the plus sign, he will say what kind of data you want to add. Here we are now very simple. Let's add a string type data here. Let's write it here. For example, our ASD is a data of our string. Similarly, let's add another numerical data below. Can we write S in the numerical data? Can't write it in, can it? So here we write a 123, and then similarly, we add a Boolean value below. Is the Boolean value flight armor? These 3 are some basic data we have learned before. Therefore, for a one-dimensional array, we can select a type of our basic data in a cell and add it directly. Similarly, the following also includes our colors and resources. Colors and resources are actually a special type of string. Will we not give you a demonstration? Then, for our arrays and objects, after we have conducted an in-depth study of our 1-bit array object, we will demonstrate the use of setting a certain type of field name array, or object in a 1-bit array. Then here we will demonstrate such a result. We can see that we click the plus sign here, and then we can enter a series of values in the corresponding type after selecting the corresponding type. When we enter a series of values, the initial value of such one-dimensional array will be negative. Now that we have negative initial value, we will print such a dimension in the workbench group. What kind of effect is it printed out? In the same way, we add a button at the bottom of the page and change the name to our printing. Just now, I told you something. When it is clicked, what feature will we trigger our one-dimensional array? Yes, it is a feature like printing the current value. We will trigger the feature of printing the current value to carry out a preview. Similarly, right-click to open the check, then switch to Control, and then click a print. We'll take a closer look here. We can see that when we appear, here is the value of one-dimensional array, and here is the value of one-dimensional array. Have you guessed what such a 4 means? That's right. The length of our array is 4, so if you see a type of such a bracket, it proves that it is an array. Then it is surrounded by a small bracket in front, and the number inside represents a length of its array. We can intercept such a content, and let's make a one-to-one comparison. For a single digit or so, what do we declare for the first type? It's a string, right? So at present, its SD is SD, right? Then next, we declare a numeric type, so it's 123 is our blue 123, and then down is our Boolean type, and then we open it, so now it is a true, and then up, in our third position, we write an aston in here, so is it in our third position? Just print out a value of aston? So, we have a very intuitive feeling here that one-dimensional arrays can help us reduce the use of our variables. For example, if we want to store a user's information and multiple values here, for example, there are various kinds of paper in the user. If we want to start from his name, his age and his place of residence, do we want to add 4 variables? For us to use 1 digit, does it start from our 1 just a variable? This is actually that we often use a feature in our array to sort out in batches, and help us to carry out an archive-like feature. Here we first sell it and destroy it, and then paste such a button. We can see its next feature, and then there is a feature called our assignment feature. Assignment feature is also non-assignment function. One of the most important functions is that we change the name of a button here, which is our assignment. Since we want to assign a value to this kind of one-dimensional array, we must see what the value of the one-dimensional array looks like. Have we just printed it here? You can see the characteristics of the value of a one-dimensional array. It is enclosed by 2 square brackets, and then each element in it. If it is a string type, it is enclosed in single quotation marks, separated by commas, and then its second character. If it is a numeric type, write its value, and then use a comma. The next variable is separated by commas. So note that here, if we want to assign a value to our one-dimensional array, what is its basic model? First write a square bracket, then write its corresponding value in it, and then divide each corresponding value with a comma. Therefore, here we can copy a digit. In the first step, we put a bracket, and then we write the first value. Here we write a prop like this. We attach such a value to it upside down. For example, the first value is our aston. What is aston? It's S, right? So let's put single quotes, and then write an aston in it, and then what are we going to do? Put an English comma, right? Perform a split, and then the next one is our Boolean variable. True is our true. Then type a comma to split, and then our 123. Then type a comma to split, and then our astast, right? It's our string, so we need to use a quotation mark in English and write asta here. In this way, you see, we have completed a style of writing a 1-bit array. When we assign values, we can directly assign values to our 1-bit array. Okay, let's take a look at the preview. Similarly, we first print its original value, then we copy it, and then print it. We can see that this is our new value, and then whether the new value is such a value that we write against it, and then write it out. Then this is our assignment operation, and then similarly, we add a button when. However, the point is that we start, and let the one-dimensional array perform an operation of emptying the array. So what is the function of this button? That is, we clear it. When this button is clicked, we trigger the operation of clearing an array. After that, an array will print its own value. Let's preview it. We can see that its initial value is ASD123 true Aston. Then, after we click empty, we can see that it becomes a blank one-dimensional array. Note that even if this one-dimensional array is empty, it is not now, it is not empty, but a structure of an array, that is, we have a square bracket. So if we assign a value to an array of bits equal to such a bracket, it is actually equivalent to performing an empty operation on it, and then we will look at its next action. In the same way, when the button is clicked, we let it perform the event. When it is clicked, we let our bit array perform an operation of adding values. You can see in add values. Here is a specified variable value, and you can also select the value that we fill in ourselves. For example, I want to fill in 112233, and then there are two ways to add it, that is, either to the beginning or to the end. Here, let's first demonstrate a method at the beginning, that is, when it makes a click, let it add a 1233 to the beginning. Therefore, this is not an addition operation. Then we will take a look at the next function of our bit array. When it is clicked, we also let our one-dimensional array perform an action. This is called adding multiple values. You can see that what is written in the introduction here is the value added to the end of the array. You can get multiple elements separated by a comma for a single digit. This is okay, so let's try it on our side, such as 12, 2 or 3, 3, 4, so we add multiple values. Let's have a preview. Similarly, click this button and then click print. You can see that 1, 2, 2, 3, 3, 4 is added in the back. Of course, if we want it to add the value of one of our arrays instead of automatically assigning it to us, we can add such a bracket here, and then we can have a preview, and then click the same button to add it, and the added value is our numerical type, not our word string type. Here we change a business card to add multiple values. President Tang, let's add another button under the page to let him do. Let's click to have a look. When this button is clicked, what is the action of a digit? You can also see that there are inserting a value and inserting multiple values here. Here we will demonstrate that inserting a value inserts a value. Here we can select a value and write an index of the insertion position. Is this the same as inserting a position? When we learned the string before, just exactly the same. Let's take a look at such an array, A4 and D123. This is its D0, right? So if you insert it, it's in D0, then it's out of position 0, right? So it's equivalent to which position you're in. It's equivalent to which position you have to give up. For example, if we make a difference in position 2, such a Boolean variable will naturally fall back. So let's try here. The value of the insertion position is the new value, and then the value of the insertion position here is 2. So far, let's take a look at its actual effect. When we click such a button and click print, we can see that the value of our 012 in position 2 is swallowed later, right? So if you want to insert a value in a certain position, you can write it in a serial number of that position. As you can see here, a 0 written in front of it actually proves that ASD has a serial number of 0123, and a 1 written in front of it, which means that the need for 1233 is 1, and so on. Therefore, through such a value, you can know exactly what its current serial number is, and then insert only multiple values, which is almost similar. We won't insert it here, a demonstration for everyone. See us in this button to let him to add event. When he is clicked, trigger our one-dimensional array to delete value of a feature. Then first, we delete the specified value. Before deleting the specified value, have we seen it when learning our string? That is, as long as it has such an element, we will delete all the values of such an element. Let's add another one here. For example, let's have another string here, and another one, and Aston is in the string, and there is only a 123 in the value here. Okay, let's ask him to delete it. Then when such a delete button is clicked, delete the specified value. Let's come to an Aston, let him delete all the values in Aston, and then delete it. Let's print another bit array and show our paper. Let's take a look at the default value in the preview. We can see that it is ASD, and then 123 places of Aston 123. Until we click delete, and then print it, we can see whether all the values in Aston have been deleted, so Aston has no more, so this is a common method to delete the specified value. Similarly, in addition to deleting the specified value, it has a function to delete the specified location value. For example, if you want to delete the index of a location, just delete it. Here's the simplest example. For example, I don't want such a Boolean variable. It's at position 0122, right? Is when I click here to select a position 2, and then I will make a preview. When I click delete, I can see that the position 2 is missing. Some students will ask, if I delete multiple values, do I need to add multiple such actions? In fact, if we want to delete multiple values, we can use the array to carry out a package. For example, if we want to delete all the 3 positions such as position 0, position 2 and position 3, we will use the numbers to package them. Let's preview again, and then print the value of the day first, and then we can delete them. We can see the 0 position are all the 3 values of position 2 and position 3 deleted, leaving a value such as 1, 2, 3, Aston, and 123. So if you want to make a multiple deletion, you should pay attention to separating it with commas, and then you can put the serial number you need to delete, that is, a corner mark of its current serial number, in the index of the deleted position. Next, we will remove duplicate values, which is very easy to understand. That is, if there are duplicate values, he will help us remove them. Here, let's take a look. First, when printing, the first value is a value like Aston. Then, when I click a deduplication, we can see such a 123 and the following Aston, because it has appeared in front, right? So this is a repeated value, and then it is deleted, and then removing the repeated value is also a feature that we often use, and then we move down again, add a button, and we will see what kind of feature it has. Here, let's click to set a value. After setting a value, it needs to fill in 2 parameters, the first is the index, and the second is the corresponding value. Let's take a look at the value in our one-dimensional array. We print it, intercept it, and put it here. Then we can select 0, 1, 2, 3 for the index here. For example, what does Aston call the reform value in position 3? It's called qui. Let's change the value of bit 3 to a qui. Similarly, let's click again to let our 1-bit array execute something, that is, print the current value. Let's have a look. Similarly, when we print by default, it is such a content. After we choose to set a certain value, we expand such an Aston, that is, a value of our position 3. Does it become qui, that is, the usage of setting a certain value? Similarly, we can also set multiple values, so that we can make a comparison. For example, if you need it on a certain serial number, you can write it in directly. For example, if we want to change all 2 Astons here, we need to change the value of position 3 to qui, and I want to change the value of position 4 to ASD, and let's see the same preview again in effect. Let's print it first. The default value is like this. Then we click on such an event to trigger it. We can see whether Aston in position 3 and Aston in position 4 have been changed to 2 values such as qui, A and SD through our event. This is how we trigger such an event by setting the value. Similarly, we add another button under the page. We trigger it through event. When it is clicked, we call the value of our array. What can we do next? Note that next, we will enter a very interesting search value called our search value. What does the search value mean? When you search for a certain value, we will return the index of the word to you. For example, here we will select a search value. For example, in our current number, I will let him search for the value of Aston. When he finishes, we need the application system to perform a debugging to record the debugging record value. You can see that when we click search, it will automatically come out incomplete, so it proves that there must be its associated parameters in the drop-down menu, right? So we click down the menu, and there is a search result here. Here we comment on it, and the above is the search result. When we see the preview, we print out the default value, and then we search for a value. What did we just search for? Is it Aston? So look at 0, 1, 2, 3, so he found Aston in position 3, and reflected such a 3. So you also know from such a search value, that is, as long as it receives the first one that meets the conditions, it will directly return its current serial number to you, that is, the corresponding 3 in front of it, so the latter 3 will not return. Some students want to ask, if it is a non-existent content, let's search here in Aston's paper. Let's confirm again. When it prints like this, when I click, I can see that it returns a 1. What is 1? Is 1 in front of 0? So, please note that whenever it returns 1, it means that there is no such value at all. You also need to remember such a return result. Then there is an operation to search for multiple values below. We click to search for multiple values, and we write Aston in the same way. Then we refresh here, and this is a return result. So this is a result of our search for multiple values. Let's preview it. Print the same value first, and then click this event to glance at. Yes, please note. What does it return after we search multiple? Because does it return an array? There are several elements in the array. Does it write a 2? What does this 2 mean? When he searched Aston, he found 2 such elements. Where is the first Aston? Did you write 3 in front, so you can see if the first element of its search results is 3, and then you can see if you searched Aston again. Where is the second result? At 4, right? So the second element is 4, so if you use the search for all values, it means you have to get all your positions. Since there may be multiple positions, its return must be an array, so here it will return a value of a one-dimensional array, and then give you a current serial number. Next, we randomly extract a value, which is also very easy to understand. That is, after I perform random extraction, I pull it here. The above is our extraction result. See our click time to see if this is our original array. When I click, he knows ASD, and then click again the next time he knew 123, and then he said Aston, and then he said 123, and then he said Aston, and then he said everywhere. I asked you a question, randomly select a value. If I want to add a little bit of its feature, I hope it randomly select a value, and it is the previous value. What should we do for non-repeated random extraction? Everyone attention, my limitation is that the front end does not repeat random selection. How to do? Here, you can have a big look. Will I draw one of the values here after I draw it here? Then where do I draw it every time? I draw it from this 1-bit array. If I don't want to be random, I can delete it from this 1-bit array. For example, when I draw a result, I delete it, and then I print out our one-dimensional number to see if it is complete. I draw such a value for each drawing, and then delete it. Then I let a bit array look at its result again. Such an effect. Let's take a look at the preview here. Let's click print first. It has 6 elements, and then we can randomly select one. What is it? Got Aston, right? Then he deleted all the values in Aston. So let's click what we got here. It's our 123, right? He deleted all of us. Then click again. It's roughly true, and then it points to Aston. Then smoke again. After taking Aston away, is there nothing in it? Of course, what we use here is to delete all the specified values. Because there are duplicates in the settings of our array itself, when we delete the specified values, it will delete multiple such values at one go. However, if we are in the existing knowledge structure, can we just ask him not to delete all of them? We will delete one of them value, and then retain one of the values. This is also possible. How do we conduct an operation? It will be a little around here relatively, but I also share it with you to facilitate a logical construction. Here, we first disable these 2 papers. Similarly, here, we first select our one-dimensional array, and let it perform what operations? Do we remember that we learned a content just now, called our search value? What is our search value? Is to search for a value and return its subscript, right? So here I search for a result we extracted in the search value, and now that I have obtained such a result, can I get a serial number of it? Then I'll call what's in our one-dimensional array. Delete the specified location. After extraction, is the search result a coordinate of a specified location? So delete the value of its corresponding subscript. Similarly, after all this, I let the EBIT array perform an operation to print the current value. Let's continue to have a look. Friends, let's take a look at the default 16 data. When I deleted it for the first time, I can also see that he deleted one Aston. Is there another Aston listed here? In this way, I click again. It deletes one 123. Is there still a 123 in it? I click again. He deleted 123. There is number 123 in it, and then click again. Aston has number 123, and then click again. There is no place, and then there is no ASD, so in fact, there are many methods for you to do such a series of effects. That is why we say that this part of our data processing is a very complex content, so as we accumulate, we slowly improve the level of our use of data widget, and randomly select one value. We do it here, because we change it to randomly select one. Okay, then we add a button. We do an event first. Similarly, when it is clicked, we call our one-dimensional array, and then execute a maximum value and a minimum value in the drop-down menu. This is very convenient, we directly ask him to obtain a maximum value. Similarly, he naturally comes out with a completion. What does it mean? Note that there is a value in the following associated parameters, so we use the debugging record here. Select a maximum value in the drop-down menu, and then annotate it above. This is the maximum value. Similarly, we can copy and paste this thing. It can get the minimum value in addition to the maximum value. Therefore, we can print a maximum value and a minimum value together. Okay, let's preview one of the effects. First, let's print it. It's actually very interesting to see that we are in a one-dimensional array. It has our text type, our Boolean type, and our numerical type. If I say that we want to print a maximum value and a minimum value, how will it make a trade-off? Let's click here first. He said that the maximum value is 123, and then our minimum value. Therefore, we are very confused here. Why is the maximum value 123 and the minimum value 1? We can tell you first, because first of all, the first one is 123. One thing is, when we want to execute, we judge its maximum and minimum values. The function is that it will first convert all the values into our numerical variables, and then judge how SD is converted into a numerical variable cannot be converted into our numerical variable, so it does not have the same 123. It itself is a numerical variable, so it can be 123. That's the problem. What is it? Is it the same? Did we tell you before that if you want to forcibly convert true into a numerical variable, it is 1, so in this transformation, true will automatically become a value of 1. That's why when we search our minimum value, there is a 1 here. In the same way, there is a 123, so far its maximum value it is 123, and the minimum value is 1. Here I can do a little extension for you. For example, we add a value here, and we add a value of string type, such as 112233. Let's preview it again. Here we change the name, here is our sorting, here is the last feature. Let's demonstrate it together. When it is clicked, we can see that there is a feature in such a one-dimensional array, which is called the function of combining the array to the string. Then we can see that when it clicks to combine the characters to the string, it is not as a string generated. Therefore, on our side, we add a text variable as our string to receive it. When it is clicked, we assign a value to our text variable. What is the assignment content? It is an object after it is converted and merged, and then we print out our text variables to have a look. Let's preview it. Similarly, let's take a look at the original, and then click such a merge here. You can see the value of the text variable here. What does it become? SD123 output 20T, 20T, 123 123, is it almost exactly the same as the value here? But it becomes separated by commas and placed in our text variables. In fact, this is a result of its merging, and its merging automatically adds us with such a comma, but when it is merged into a string, it does not necessarily merge completely with commas. This is a function that you can use. It's this function. Just search it yourself. Here's an additional point for you. What we didn't finish in the text variable before is our split text variable, right? So here we add another button, change the name here, change the name here, and split it here. The name is our combination. How to split it? Is it an action in our text variable? So when we click, we perform a function of splitting a string for a text variable like ours, yes. You can see that it reminds us that we need a separator. What is the separator? The separator is actually an effect here. We can see that a one-dimensional array here is merged into such a text variable with a comma as an interval. So if we want such a text variable to return to a one-bit array, what is its segmentation? Is it a comma? So here we put the comma of the split compound into it. In the same way, because it is a special character, we need to use single quotation marks to enclose it. This is one of our commas. After the split is completed, we use our application system debugging record. Let's take a look at the result of the split. Here we can comment that the above is the split as a result. Let's preview one of the effects. Let's print it first. This is its original value. Let's merge. After merging, will there be a value in the text variable, and then we split it? Will it become such a series of types after splitting? Of course, so far, it has been automatically put in, so when it is merged, it does not know what type it should be. Therefore, the default types are all string types. They are all stored in a business array, which is equivalent to a result of its splitting. Therefore, for a one-bit array, it is separable to convert into a text variable for storage, and then finally turn our text variable into a one-dimensional array for use through a function. Of course, what are the benefits of numbers? Of course, there are many benefits, because it is very convenient for us to assign values, monitor a value, set a value, and delete a value. In addition, when we learn about loop creation and conditional volume, we can better find the advantages of arrays, so arrays will be used in our subsequent use. Finally, let's talk about how to reference the values in a one-dimensional array. We add a button here, and we change the name to our reference. When we click on the value of the reference one-dimensional array, we go to get the value of the one-dimensional array. When we see this, we trigger it through the event. When he clicks, we do not copy a certain object, and we directly debug the application system, make a check in the record. Please note that the debugging record of the application system is actually equivalent to that we are just using a formula editor here to facilitate us to view a value. What is the equivalent of this? Here I'd like to show you a little to facilitate your understanding. Here we add a text and put it here. Then when I click reference, I assign a value to such a text. What is the content of the assignment? It is the object in our one-dimensional array. When I select English numbers here, I can find that there are many values to choose from. First, let's look at the first, that is, we directly reference the value of such an array, so I choose the value of a one-dimensional array here. Similarly, in the debugging record here, I also choose the paper of one-dimensional array, and then I click a preview. After I click the reference here, I can find that the following text copies the value equal to the one-dimensional array, and then we can see the value of one-dimensional array in the debugging record here. So in fact, we are here for copying. We say debugging record in terms of debugging records. We are all using the values in a one-dimensional array in a disguised form. So here, I don't need to assign values to demonstrate, but I will directly demonstrate the usage in our debugging records. First, we name it directly as the value of our one-dimensional array, and then we copy and paste such a debugging record, and then we change the second debugging record to become the number of elements of our one-dimensional array. So let's take a look at the debugging below to become the number of one-dimensional arrays. Similarly, let's make another copy here, and let's make another reference. Besides the number of elements, what else? There is an element and an element. Here is a very important point for us. If we want to refer to an element in a number, how do we apply it? We can see the following side of it. Let us write a subscript, and we can directly write the value of the subscript after the colon. We can see that there are 7 values in such a one-dimensional array, so if we have a corresponding element, we will write its subscript. For example, I want to reference such a 123 in position 1, so I don't subscript here when I click reference, or I can write 1 directly, and then here is a 1-bit array, the value of position 1. Similarly, when we click on application, we can see if the number 011 is 123, so we take out the value of the number 1 through this method. Similarly, there are a lot of techniques that we often use. For example, here is our one-dimensional array deduplication search value into string reverse random sorting, including random value, maximum value, minimum value, some average value. What are these? Are these things we did through event just now? In fact, in addition to time, we can also get such a value in the moment we quote. For example, I click a value of deduplication value here, in other words, it will directly give us a result after deduplication. Can we see that there are 2 astons here at present? Let's take a look at the preview. When I directly click the reference, I can see whether there are 7 such elements at the beginning. Then, after 1 deduplication, whether the repeated elements are cleared by it, leaving only 5 elements. Therefore, we can directly reference the value of the deduplication value of a one-dimensional array, and directly get the value of the deduplication value of a 1-bit array through such a method. So, similarly, if you need to get a value after the array is sorted, you can also directly use such a method, for example, a value in reverse order, and then here is a one-dimensional array. Similarly, we can also have a look. When I click the reference, it is a value such as ASD123123 at the beginning, so it's easy we have reached a value after the order. Similarly, we can use other methods to calculate the result of such a point. For example, we just demonstrated the number of elements of the deduplication value of the one-dimensional array. You can see that since I have already gone too heavy, I will look at its number of elements, so it will get a deduplication value first, and then calculate the number of elements after deduplication through the deduplication value. So here, if we click a reference again, we can see that the number of elements he gets after he reduces becomes 5. Therefore, this is to point a result, and then get a result, and then get a series of corresponding values through a point, which is very, very easy to see in the yellow label. Then this series has already been talked about when we talked about event just now. Here we will talk about another one. We will use a little more, that is, the average value in our one-dimensional array, and the sum of it. When we use the average and sum of one-dimensional arrays, please note that we need to turn all the numerical types in one-dimensional arrays into a numerical variable, that is, if many values are not numerical variables, it will forcibly convert them into our numerical variables. As for the content of this series of references, we will often use such a series of functions when learning our data processing later. You can develop a preliminary concept here, and then deepen and consolidate it. That's all the content of this section. Thank you for watching.